we're going to start with the second activity. And this is pretty much a little math problem you're going to have to do. And don't worry, it's not bad. And there's a little bit of dark humor in it. So when you're done, I want you to switch the papers. And I want you to grade each other in the following way. Assign 0 if you think it's completely wrong or there's nothing on the paper. Assign 1 if you think it's like, on the right track, but the person might still end up needing to borrow some money over the summer. And 2 if it's completely right, if you think it's completely right. So just 0, 1, and 2.
But what if I'm wrong?
Well,
see?
Well, and you have to explain yourself every place where you think the person made a mistake. So write down an explanation if you think that they made a mistake and why you think that's a mistake.
I thought it was left over per month. Can I have a 1 point? What are you going to give me? That's what I did. Out of 2. Of course not. We're doing it. I do have lots of Oh, thank you. You're very generous. Because I'm a scientist, right? I work with numbers, like not complicated numbers.
What's the first thing that we try to teach students in science class? There's many different ways you can teach or do the same problem. Do they listen to us?
No.
But when you were looking at each other's papers, like, oh, I could have done it this way. Oh, I could have done it that way. And I'm sure if we collect all the papers, we can find at least 5 or 6 different ways that people were doing the budgeting. And if I try to tell students, oh, you can solve this problem 5 different ways, which way would they try to do it? Test? However textbook does it, or the very first one I showed them. Whether or not they understand it. So what's the second thing that we have a big problem in science classes? Getting students to really understand what's happening instead of just regurgitating all the formulas. And when I forced you to actually grade each other, did you really have to understand the problem? Does it force you to understand the problem? And as I said, and the final thing that I found that this kind of approach helps with is the formula mining technique. And do you guys know what I mean by that? It's like you see some whatever letter that represents whatever in a book, and you go thumb through the book and look for the formula with that letter again in it. And you're going to use that formula whether or not it actually the letter represents the same thing. Like for example, T in physics can represent time, it can represent period, it can represent temperature. So you get frequently people substituting formulas for temperature into the formulas for period. It's because they're just thumbing through the book finding. And doing this exercise actually forces them to evaluate whether or not their peer used the right formula. How many of you remember formulas from when you were in school? But how many of you, if you understand something, how many of you know which book to go back to look for formulas? Exactly, because you understand what's going on, and you know, okay, I know what's going on, I know where to go look for it, or I don't know if the formula has a squared or like a cubed, or if it has like 1/2, or it has pi in front of it. It doesn't matter. What matters is that you understand physically what's happening in your system. And having students do this exercise is doing exactly the same thing. It's detaching them from just chugging through the formulas, and it's forcing them to understand real physical concepts that we are trying to teach them.
Well, we wanted just to summarize really briefly some of the benefits, which I hope you've actually experienced by doing active learning today. The first is that there's a clear benefit to students, and in Debye and Korana's work, you can see that there was a change in terms of learning as expressed through grades, that student in control groups versus the participant group, that the participant group did a little bit better. But the more important part is the ability to communicate with students about their learning process, to know what their knowledge and skill gaps are, to be more conscious of it themselves, that they're able to model and improve some of the academic skills. Like, I've learned a budgeting process from working with Mark and Virginia just today. So, I mean, I think that that's a really tangible effect of this kind of process. And that you share strategies ultimately, and you work in a learning environment more efficiently as a result of seeing how other learners navigate the process. There's also, for instructors, a lot of benefits that we haven't dwelled on quite as much because we've taken the student perspective on this. But all of us provide, hopefully, a lot of feedback to our students. And as I think Korana was really emphasizing, we can tell them that this is the learning process, but it doesn't register quite as effectively as when they experience it themselves through peers. And so there may be a form of feedback that you give that is actually better administered peer-to-peer than through faculty, or that the faculty, like in Debye's case, play a reinforcing role, like how she commented upon the commenting, but the primary thing was what the students were saying to each other. If structured correctly with clear parameters, which I think both of our presenters have emphasized, it can be an engaging classroom environment. We'll talk about some of the challenges just really briefly at the end. And that basically you're able to identify student needs a little more readily than through major exams or high-stake assignments and that kind of thing.
At the beginning, they never do it. So I just say, okay, can you form some groups? And they just stay where they were at the beginning, you know? So I had to really go there and physically take them and say, okay, you three, you create a circle, you four, you create a circle. So it was really time consuming.
It is, except that, so in math and physics classes, it's a standard to work in groups.
Okay.
And I think the reason why it's a standard is because when we tell them, the very first discussion section that we have with them is we tell them, okay, you're going to be working in groups. So they know that that's what they're expected to do in class. So the very first minute when you see them, you know, after you introduce yourself, you tell them, okay, we're going to be working in groups.
Okay. That's quite different because in our case, sometimes they work alone, sometimes they have to work in groups. It's nice when you give them assignments, to take-home assignments, and you say, okay, you have to work in group and create, I don't know, like for example, in Second Life, an online exhibition. In that case, they have to do it, they understand that it's what they have to. But in class is more difficult, at least this is my experience.
I find that a lot of times when I give an instruction and I don't see anybody really moving, that it's because they're not sure what I'm really asking. So rather than say get in groups, because then you're like, well, how many and what size? If you go, I want you in groups of 3, I want a group here, a group there, a group there, a group there, and give them a little bit more instruction of exactly what you want, I think you'll find that they'll move a little faster. Yes.
And
Well, you know, I mean, but
it's
it's
really
a lot of
what
times
they
it's just
need
not,
to-
they're sitting there kind of like going, okay, we're supposed to work in groups, how many, where, you know, usually it's more information.
And the other thing is also, we always work in groups, and they were sitting in groups when they were doing these things. You know, it doesn't mean that if you pair them up in groups, they still can't work by themselves. It's just that you don't let them talk to each other.
Yeah, because another point is then you form the groups and you see that somebody continues to just work alone.
That always happens.
It
and
always happens, and then what you can do is that you can switch around groups.
yeah, and so every time I
Yeah.
have to change.